Good morning. Today we start our second lesson, that is coordinate geometry. So in lower classes, you have learned the meaning of the word coordinate and even how to place numbers on a number line and how to find distance between 2 points. So just very quickly, let's recap. Let us say this is my x-axis where the origin is in the center and positive and negative numbers in their respective position, then you know how to find the distance between any 2 points. Let us say between A and B, you know the distance formula will be bigger coordinate minus the smaller coordinate. That is, let us say x2 is the bigger coordinate, x1 is the smaller coordinate. So in this case, 3 is the bigger coordinate and minus 2 is the smaller coordinate. So the answer that we get is 5 units. So if 2 points are on the x-axis, just by subtracting x2 minus x1, you can get the answer. Let us talk about the vertical axis, which is the y-axis, where the positive numbers are on the top and the negative numbers at the bottom. Again, if you want to find out distance between 2 points, let us say A and B. Again, you can use the same formula, bigger coordinate minus smaller coordinate. Let us say y2 is a bigger coordinate and y1 is the smaller coordinate. So here 2 is the bigger coordinate and minus 2 is the smaller coordinate. So when you open this will become 2 plus 2, which is 4 units. So you see, when the points are on the axis, it is very easy to find the distance between the 2 points just by using bigger coordinate minus smaller coordinate. But when we talk of a quadrant system or a plane where we have both the axes x and y together and we have any point in a plane, let us say A and B, and we are supposed to find this distance AB, then you can see here it cannot be just one single x2 minus x1 or y2 minus y1. As you know, this A has two coordinates, x2 and y2. Similarly, B also has two coordinates, let us say x1 and y1. So just by using x2 minus x1 or y2 minus y1, it would not be possible to get the distance between AB. So for this, we use Pythagoras theorem. So you can see, if we draw two perpendiculars like this to get a third point C, then the standing distance is parallel to y-axis and the distance will be y2 minus y1. Similarly, this horizontal line is parallel to x-axis and this distance will be x2 minus x1. So now you can see the two sides of the right angle triangle are y2 minus y1 and x2 minus x1. Then using Pythagoras, we can definitely find out the distance AB. So distance AB, which is the hypotenuse, will be nothing but square root of one side square plus second side square, which is the Pythagoras theorem. So one side square is x2 minus x1 the whole square and the second side is y2 minus y1 the whole square. So from here we get the distance formula to find the distance between any 2 points in the quadrant system. So let's use this formula and try to solve some sums today. Let us say I have A coordinate 3 and 2. B coordinate is 4 and 5. Now I have to find out the distance between these 2 points. So first let us assume A to be as x1, y1 and B to be as x2, y2. Always remember, the first one is the x coordinate, the second one is the y coordinate. It cannot be x1, x2 or y1, y2, right? It has to be x1, y1, x2, y2. So now let us say we want to find out distance AB. Let's write our formula. It is x2 minus x1 the whole square plus y2 minus y1 the whole square. You should always remember this also, that this formula can be written as x1 minus x2 the whole square plus y1 minus y2 the whole square also. It doesn't matter, because even if you subtract it anyway, the first number from the second or the second number from the first, after squaring you will definitely get the same answer. So let us now substitute the values that are given. Now you can see in the formula we have x2. x2 is 4. Then we have a minus sign in the formula. Then x1. So you can see x1 is 3. So 4 minus 3 the whole square plus. All these are from the formula, right? Next is y2. So you can see y2 is 5. Then minus sign from the formula. y1 is 2. So 5 minus 2 the whole square. So let us solve this now. 4 minus 3 is 1. So 1 square. 5 minus 2 is 3. So 3 square. So the answer is 1 square is 1. 3 square is 9. So the answer that we get is root 10 units. So what we got is that distance AB is root 10 units. Let's do another formula. Let us say C is minus 2 minus 1. D is 3 comma 3. So again I assume the first point as x1 y1, second point is x2 y2. Let's find out the distance between the 2 points then using our formula x2 minus x1 the whole square plus y2 minus y1 the whole square. Now here again x2 is 3, minus sign from the bracket, x1 is minus 2, the whole square, plus y2 is 3, minus y1 is again minus 1, the whole square. Always remember to write the negative sign numbers in the bracket so you understand how to solve. Now you can see minus of minus is plus. So this will become 3 plus 2 the whole square. Plus again here minus of minus is plus. So it will become 3 plus 1 the whole square. So what we get is 3 plus 2 is 5 square and 3 plus 1 is 4 square. So 5 square is 25 and 4 square is 16. So on addition of these two, you will get your answer in units. It is not necessary that every time you should get a perfect square. So 20, 30, 36 and 5 is 41 units. So this becomes distance CD. Only thing you should remember in these formulas is when you are substituting the values, the signs that you are carrying should be proper. If your signs you don't carry it properly, you will get the wrong answer. Let's again go to one more sum. Let us say E is 0 and minus 2. F is minus 1 and minus 3. So again, let us say we use our distance formula. Distance E comma F is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. I take my first point as x1, y1 and the second point as x2, y2. Let us substitute the values now. x2 is minus 1. So minus 1. Next the minus sign from the formula. x1 is 0. The whole square. Plus y2 is minus 3. Then again a minus sign and then y1 which is minus 2. The whole square. Before we open the bracket, first try to solve it out. So it becomes easier. So you can see minus 1 minus 0 is nothing but minus 1 square. Now here minus 3 and minus of minus 2 becomes plus 2. So now minus 1 square is 1. Minus 3 plus 2 is minus 1. So minus 1 square. So what you have minus 1 square is again 1. So the answer that we get is root 2 units. So this way, using this formula, we can find out distance between any 2 points. Similarly, using this formula, we can also decide whether the points are collinear or no. So in lower classes, we have learned how to find the property or how to decide whether the points are collinear or no. Let us say we have 3 points ABC which are collinear. Then you can see this distance AB plus distance BC should be equal to distance AC. So if 3 points are given, what we have to do is find the distance of the 3 points, then add the 2 small ones and see whether it is equal to the bigger distance or no. So let's take one example. Let us say I have A minus 3 comma 2, B 1 comma minus 2 and C 9 comma minus 10. Now I have to decide whether these 3 points are collinear or no. So for this what we do is we find distance AB, distance BC and distance AC. And then we will decide whether the points are collinear or no. So let's start with distance AB first. So you know the formula that we have to use is x2 minus x1 the whole square plus y2 minus y1 the whole square. Now A is minus 3 comma 2, which I'm taking it as x1 y1, and B is 1 comma minus 2, which I'm taking it as x2 y2. So let's substitute it in the formula. x2 is 1 minus x1 is minus 3 the whole square, correct, plus y2. Now y2 is minus 2 plus y1 is 2. Sorry, I have to put a minus sign here. Whole square, right? So now you can see 1 minus of minus 3 will become plus 3. Next, minus 2 and minus 2 will become minus 4. So 1 plus 3 is 4, 4 square is 16, minus 4 square is also 16. So we get answer as 32. Right? For the time being, let's leave it as it is. Then I'll show you why we have to simplify this further. Let's go to distance BC now. So B is 1 comma minus 2, C is 9 comma minus 10. So now this is x1 y1, x2 y2. So let's find out distance BC using our formula x2 minus x1 the whole square plus y2 minus y1 the whole square. So now x2 is 9 minus from the formula x1 is 1 the whole square. Now y2 is minus 10 minus from the formula sign and minus 2 is y1. So the whole square. So now you can see 9 minus 1, that is 8 square. Now you can see minus 10 plus 2. Minus 10 plus 2 the whole square. So this will be nothing but 8 square. Minus 10 plus 2 is again minus 8 the whole square. So which is 8 square is 64 and minus 8 square is also 64. Right? So that becomes 128. Next, I leave it for the time being as it is. Then we find out distance AC. A is minus 3 comma 2 and C is 9 comma minus 10. So again I take A as x1 y1 and C as x2 y2. Let's find out distance AC. Again our formula x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's substitute the values. x2 is 9 minus from the formula x1 is minus 3 the whole square. Next y2 which is minus 10 minus from the formula x1 the whole square. Now minus of minus is plus, so this will become 9 plus 3 the whole square, and this is minus 10 minus 2 will become minus 12 the whole square. So here again you can see 9 plus 3 is 12 square plus minus 12 square. So 12 square is 144 and minus 12 square is also 144. So the answer that we get is root of 288. Right? Now I had left all these three as it is to show how we are getting. Now you see, if you want to add the two small distances, that is AB and BC. If I want to add these two and check whether it is equal to the bigger distance, you can see in this case AC. I've just given an example. AC is the bigger distance. You can see compare from here 128, 32 and 288. So I'm getting AC as the bigger distance. But to add these two, the number inside the root should be same. Then only you can add. So that is why we simplify this to get a mixed assert. Now this can be written as 2 into 16 or nothing but 4 root 2 units. Right? So I got a root 2 here. Similarly, I should be getting a root 2 here also. So now this can be also written as 64 into 2, which is nothing but 8 root 2. So now here see, you got a root 2 here and we got a root 2 here. Similarly for this also, if I want to remove it, I have to write it as 144 into 2, which is nothing but 12 root 2. So I got the three distances. Now I'll just write them together so I can explain now what we did, right? So let us say distance AB. I got it as root 32, and this root 32 I wrote it as 16 into 2, which was 4 root 2. Then distance BC was root 128, which I wrote it as 64 into 2, which was nothing but 8 root 2. And distance AC, I got it as root 288, which I wrote it as 144 into 2, and I got it as 12 root 2. So now these are the three distances we have got. So now from here you can see all three are having the same number in the root sign. These two are small distance and this is the big one. So these two additions should give us the bigger one. So just let's see whether we get it or no. So distance AB plus distance BC is equal to 4 root 2 plus 8 root 2. You can see root 2 can be removed outside common, and what remains inside is 4 plus 8, which is nothing but 12 root 2 units. So you can see the addition of two small distances is giving me 12 root 2, whereas distance of AC is also 12 root 2 units. So you can see two small distances when added together is giving me my bigger distance. In other words, distance AB plus distance BC is equal to distance AC. Therefore, A, B and C are collinear. So if these distances would not have come same, then I would have said distance 1 plus distance 2 is not equal to distance 3. Therefore, the 3 points are not collinear, right? So how do we find whether the points are collinear or no? But just finding out the three distances as we did here. We found out the three distances AB, BC and AC, and then by just adding the two small distances and checking whether it is equal to the third bigger distance or no. If yes, then we say the points are collinear. If no, then we say the points are not collinear. So this is how you should be doing the assignment that will be coming along with this video. Thank you.